Direct observation is useful for a number of reasons. First of all, later in the course we're going to talk about how we can use observational data collection as a way to identify things that might trigger or serve as some form of motivation for problem behavior. So we'll be talking about ways that we can identify antecedents and consequences, and another factor that we haven't discussed yet, that's setting events. Setting events are other things that might influence a student's behavior. But right now we're going to be focusing on using observational data as a way to monitor a student's progress. For example, before you begin some kind of intervention or before you begin some kind of instructional strategy, you need to collect some kind of baseline data to give you the student's current level of performance. You do this so that later on you can measure the student's behavior and you have a point of comparison. You can tell if your intervention has had the effect that you had planned on the student's behavior. It's also useful for identifying what aspects of an intervention were most successful. For example, you can sometimes apply interventions in steps. You might begin with one part, then add another part later, and then add a third part later. And if you have data on the student's behavior when each element is introduced, it gives you some idea as to which parts of the program might be most effective for your student. And then finally, it helps you evaluate if the student's learning. It's a way of determining if your instructional plans are teaching the students the skills and behaviors that you had planned and how well they're working, whether you need to continue the way they are or whether you need to make some kind of change. The simplest form of direct observation is anecdotal recording. Anecdotal recording is simply keeping a running log or writing down notes as things happen. It is not planned in any way, and it's actually something that I use when I go into a situation and I'm not really sure what I'm looking for. So the advantage of anecdotal recording is you don't have to plan ahead of time. You don't have to know what you're looking for. Very quickly, though, you want to move to some more systematic form of observation. Systematic simply means that you have a system in place. You have a planned method for collecting your data and organizing it and summarizing it. Systematic data collection is more accurate because you've got a standard by which you're measuring something over time. So most of the time we're going to spend talking about systematic observation systems. With systematic observation systems, we'll divide those into two broad categories. The first category we're going to call event-based. Those are methods by which you're recording each and every occurrence of a behavior. And they include counting or frequency, measures of behavior, duration or measure of how long a behavior lasts, latency or the length of time between some kind of signal and the beginning of a behavior, and then we'll talk about collecting data based on trials or opportunities. The second category of observational systematic observation is estimating procedures. There are two tools we're going to use to give us some estimate of the level of a behavior. Those include partial interval recording and momentary time sampling. You use partial interval recording when it's a behavior that you would otherwise measure with frequency, but for some reason it's impractical to do so. You use momentary time sampling in situations where you would otherwise measure the duration of a behavior. So we'll spend a little time talking about each of these data collection strategies. Frequency counting or frequency recording is the simplest form of measuring behavior. You're simply making some kind of entry each time a behavior occurs. However, as with all the methods of data collection, it's extremely important that you have a very good definition of what the behavior is. So you need to define the behavior in terms that are observable and measurable. By observable and measurable, those you define the behavior in terms of things you see. Don't get into trying to assign purpose to behavior at this point. That's something we'll be doing later, but for purposes of measuring, you simply want to record, did the behavior occur, yes or no? Permanent product recording is a variation of frequency recording, and it involves recording not the behavior itself, but some physical product of the behavior. For example, it could be the number of math problems completed, the number of cupcakes someone baked. You simply look at how many cupcakes are there, and you count them. You don't have to physically make a tally mark every time someone makes a cupcake. Here's a comparison of frequency and permanent product side by side. It gives you an example of each. Down at the bottom, look at the way these data are summarized. On the left side, you see down at the bottom, day 2, 6 hits or shoves in 15 minutes. And then you see 6 divided by 15 equals 0.04 RPM. RPM is rate per minute. Often we're going to convert frequency into rate. You calculate rate by taking the frequency of a behavior and dividing it by some unit of time. And it tells you how many events or how many times the behavior occurred per unit of time. So 0.04 means that it's happening significantly less than once per minute. On the right side, we're taking permanent product. Often, but not always, we will convert that into a percentage. We're going to see other situations where we're going to convert data into percentages as a way of comparing data across days. So when the number of opportunities is different from day to day, it's useful to convert data, frequency data, or permanent product data into percentages. It allows us to compare one day to the next. This is an example of a frequency data sheet. There are many variations of this. It's often useful to include a student's schedule on a data sheet and then record the frequency of behaviors for each class period or each activity. That gives you some additional information, not only how often the behavior occurred, but it also tells you what was going on a little bit when the behavior was occurring. The advantages of frequency recording is that it's fairly simple, and for behaviors that you're really concerned with how many times they happen, it's the right thing to do. The disadvantages, well, like all methods, you've got to have the right tool for the right job. So if it's a behavior and you're really concerned with how long the behavior lasts, frequency data is not going to give you adequate information. Also, like none of the methods we're going to talk about in this session, it doesn't give you information on antecedents and consequences. That's actually going to be a disadvantage of everything I discussed during this podcast, so I'm not going to mention it much more, but we need to do other things to identify antecedents and consequences of behavior. And unless we add something to it, like a rating system, frequency measures are not going to tell us much about the intensity of a problem behavior either. Permanent product recording is very useful when you're very outcome focused. How many math problems were completed, what percentage of these are correct. You can get all of that information from looking at permanent products. The biggest disadvantage is that it does not tell you anything about process. It's very product focused. So if you want to know more about what actually happened when something was completed, you have to observe that process. Often in the beginning, you may try doing more direct observation and then later on focus on permanent product recording once you have an idea of what the process is. For example, if a student's having difficulty performing math operations, you're not going to know how to help the student by only looking at an incorrect answer. You would want to see the steps the student went through in solving a problem. The next form of event-based recording is duration recording. Duration recording is useful when you're concerned with how long a behavior lasts. So behaviors that we would use, for which we would use duration recording, we call continuous behaviors. Continuous in that they go on for some period of time. With duration recording, you generally record the time when the behavior starts, the time when the behavior stops. The difference between those is the length of time the behavior occurred. It's useful in most cases to get data on each instance and how long it lasts. Then you can compute not only the percentage of time during your observation period the behavior occurred, but you can also compute the average length of each occurrence. Latency recording is similar to duration recording in that they both involve measuring time. However, with latency recording, you're measuring the time between some kind of cue in the environment and the behavior occurring or beginning. For example, you may measure how long it takes a student to transition from one class to another after a bell has signaled it's time to transition. Obviously, if a student was taking a long time to do that and you were concerned with shortening that length of time, you would measure latency. And you would want to see that shorten as a result of whatever your intervention was. Here's a side-by-side comparison of duration and latency. Notice at the bottom, we're computing how many tantrums occurred and then what was the average duration of each tantrum. Data sheets for duration and latency can be really simple. Generally, you want to record the date. Sometimes I will break down a data sheet into periods of the day. On this one, it's simply for each day, and then you record the time the behavior started, the time the behavior stopped. If you're using a stopwatch, you don't even have to record the time. You can just record the number of seconds or minutes each behavior lasted. With latency, you're not recording the beginning of a behavior, but you're recording some cue. That's what the symbol SD means. SD is discriminative stimulus. We'll talk about that more later, but at this point, know that it means some kind of signal or cue that should signal the person to engage in the behavior. And you're looking at the difference in time between some kind of cue and the behavior beginning. The pros and cons of duration recording. Well, the advantage is that for behaviors that when you're concerned about how long a behavior lasts, it is conceptually the simplest method to use. It's if your plan is to increase the length of time someone engages in a behavior, it's going to give you very useful information. The biggest disadvantage is sometimes it's a problem if you can't devote full attention to observing someone. If you miss the behavior ending or if you miss the behavior beginning, your data is not going to be accurate. Like the other measures, it doesn't identify triggers or motivation for problem behaviors. But we'll be talking about those things later. Latency recording is fairly simple to use. It's very good. One particular instance when I use it a lot is if I'm working with students with autism and I'm increasing their tolerance for delay. In other words, if they make a request, we want to have them be able to wait longer periods of time or tolerate waiting. And sometimes that's something we'll increase very slowly. So I use latency as the measure. How long can the student successfully wait once a request is made? You want to build that tolerance up so that the student can handle delays when they occur. It's part of life. The disadvantage, well, it's not something you're going to use as frequently as the other measures. It's very specific. Trial or event-based recording is useful in many situations. Often during instructional training, if we do some kind of teaching that involves trials or opportunities, you want to record how many opportunities the student had and then whether the student gave you a correct or incorrect response. We're going to be reporting those in terms of percentages. That way, if the number of trials or opportunities isn't the same from one day to the next, we can still compare our data. A related method is task analysis recording. Many of the skills that we teach students with disabilities, students on the autism spectrum, students with developmental disabilities, we teach functional skills, life skills. Those often involves a sequence of steps that have to be performed in a certain order. We will typically do a task analysis to identify the steps, and then we record what steps the student can do independently and what are the steps on which the student needs some kind of assistance. Sometimes we actually record the level of assistance given on each step, so we may come up with a code to indicate if the student was given a gestural prompt or a model prompt or physical assistance. Here are some examples of trial recording and task analysis recording. And these are a couple of data sheets that you could use with task analysis recording. Some of them give you a place to code the level of assistance. Some of them simply the student performed the step independently, plus or minus, plus for yes, minus for no. The pros and cons of task analysis, level of assistance recording, they can be extremely useful. I've used these methods a great deal in my work with students because I've often taught students that needed instruction on functional skills. The disadvantage is that they can be a little complex, and you have to be taught to enter the data correctly. So if you have several people recording this kind of data, it's very important that you develop a very high inter-observer agreement. Otherwise, your data is not going to give you accurate information. Now we come to the second category of observational methods, estimating or sampling procedures. There are two of these. First one is momentary time sampling. Momentary time sampling is a snapshot of behavior. So we'll divide our time into equal intervals. Let's say we have intervals that are 15 seconds long, and we're going to observe for 15 minutes. That means each minute we're going to have 4 instances of behavior we're recording. It's extremely important that you have a very good definition of behavior, because you have to be able to look at the situation and in an instant in time judge, is the behavior occurring, yes or no. A variation or a different method that's similar is partial interval recording. In partial interval recording, you are indicating if a behavior occurs at any time during that interval, yes or no. So with partial interval recording, you're just recording a plus in that interval as soon as the behavior occurs. You don't record anything else, even if the behavior occurs again during that interval, and then you start over again in the next interval. So every 15 seconds in this case you'd be making an entry. Partial interval recording, momentary time sampling are for different things. Partial interval recording, typically you're going to use it with a high frequency behavior, so it's something that you would typically count the number of times the behavior occurs. But for whatever reasons, counting it's not real practical. Partial interval recording will give you a good measure of the behavior. Momentary time sampling is used when you want to estimate the duration of a behavior. Duration recording and momentary time sampling, if they're both done correctly, will give you very similar information. The percentage of intervals of behavior occurred with momentary time sampling and the actual percentage of time the behavior occurred will be very close. This is an extremely useful method of collecting data, and it's one that I've used many, many times. Partial interval recording I've used on some occasions, but not as often. Momentary time sampling is good for things like measuring on-task behavior or engagement. I've also used it extensively measuring social skills. What percentage of intervals is a student with autism actively engaged with peers? Here's some examples of partial interval recording and momentary time sampling. A variation of momentary time sampling is called play check. or it's short for place check. This is doing momentary time sampling with small groups of students. So instead of looking at an individual student at the end of each interval, you would look at a small group. You instantly make a determination of these kids or of these students, what percentage is doing a certain behavior. Usually with this, it's how many are engaged versus not engaged. So it's a way of getting a snapshot of how engaged a group of students is. Here's some examples of interval data sheets. This one is for 10-second intervals. Obviously, if you were going to do 15-second intervals, you would have 4 columns per minute. If you were going to do 30-second intervals, you would have 2 columns per minute. This is an example of play check. At the end of each interval, you make the determination how many of 6 students are on task. It works with up to 6 students. I've tried it with more than 6, and it becomes much more difficult. So if you do it with if you have more than 6 students, divide them into small groups and do an observation of each group and rotate from one group to the next. The pros of estimating procedures, well, they can be extremely useful. They are very good for, especially with high-frequency behaviors. Partial interval recording gives you a good measure. With duration behaviors, momentary time sampling gives you a good measure. The cons, well, if you use partial interval recording to record something that you really should be using momentary time sampling for, you're going to get a huge overestimate of the behavior. So you've got to pick the right tool. Momentary time sampling is not good with very short duration behaviors. It will not do a good estimate of those. So it's more something that you're really concerned with how long it lasts. Like the other methods, these do not give you information on triggers, on antecedents and consequences. Sometimes you will, rather than collect data on an ongoing basis, you will do probes. Probes simply mean that you're going to do some short observation periods several times a day sometimes, or a few times a week. This is extremely useful if you want to measure behaviors that you don't expect to change really quickly, but you want to have some ongoing measure of. For example, you may observe a student with autism interacting with kids on the playground and look at the percentage of intervals that student is engaged with other students. You won't do that every time, but maybe you'll do it a couple of times a week for a few minutes. Then you have a point of comparison. You can say if this behavior is increasing, decreasing, or staying the same. For each of the measures that we've talked about, we need to learn to compute inter-observer agreement. Another word for this is reliability. This is a measure of the extent to which 2 observers who are observing the same person at the same time, recording the same data, agree with one another. So inter-observer agreement is our measure. We want to do this to get a measure of how good our data collection method is. The criteria or the standard we use is 80% agreement. We want our data collection to have at least 80% agreement regardless of the method we're using. For frequency recording and duration recording, we use the same formula. The smaller number over the larger number times 100 equals percent agreement. So if you're using frequency recording, it would be the smaller frequency over the larger frequency times 100. If you're using duration recording, it would be the shorter duration over the longer duration times 100. The same goes for latency, the shorter latency over the longer latency times 100. So the same formula. For interval recording, we use a different measure. We look at each observation or each interval and we make the determination, did the 2 observers agree or disagree? So we want to calculate the ratio of agreements over the overall number of observations. So the formula is the number of agreements divided by the number of agreements plus disagreements times 100. That gives us the percentage agreement for partial interval recording, and momentary time sampling. And here's some examples of different situations. Another method of collecting data that's useful sometimes is to do a peer comparison. You can do this with any of the data collection methods we've talked about. Here, typically, you will observe one student, and then you'll pick a peer, sometimes at random. Sometimes you maybe pick one or two peers. The point here is to compare your students' data to that of peers. So you want to make some kind of statement, how different is your student from other students? This is useful sometimes if you're going to have a kid with special needs be mainstreamed or included in a general education class. You can do a peer comparison with students in general education to get some idea of the level of behavior that's expected in that setting. For example, if you had a student, you wanted to determine if his level of on-task behavior was similar to that of non-disabled peers, you would go into a similar classroom, observe 2 or 3 students for a few minutes, calculate the percentage of intervals they were on task, then you would observe the student that you're considering the data for. How does that student's data compare with other learners? It has lots of applications. Finally, an ecological assessment is something we're going to spend more time talking about later. That's when you observe a student in different settings. Usually, when I've done this, it's to determine the function of a problem behavior. So I want to identify settings where the behavior is less likely to occur, settings where a behavior is more likely to occur, and then I look at differences between those two settings. Often that'll give us some clues into what triggers might be setting the occasion for problem behavior. We'll spend a lot more time talking about ecological assessment later.